Hello, my name's Dr. Randy Price and I work for the LSU Ag Center. We want to go over today is trying to use Agisfot to make a 2D map or an ortho mosaic of the camera data that comes from like a Parrot Sequoia type camera. The Parrot Sequoia type camera is an NIR camera, meaning that it has a special band or imager for NIR. It's a type of camera that has separate imagers. Usually there's 3 or 4. There's other ones like MicaSense that are like this, and they record one image for each imager at the same time. So when you download this data, you'll get like red, green, and blue images, and then you'll get NIR, and you might get red edge and red that are in separate images. Now the problem has been, and it's not a big problem, is most people will analyze this with Pix4D or something, and it just seamlessly goes in and gives you the results. But you may be a person who doesn't own Pix4D. You may have Agisfot or something like that, and we often get questions about how to get that data in the Agisfot, and there is a little bit of a technique and some things you need to know to do that. So that's what we're going to go over today. So if you're interested in that, this is the video for you. First, let's start Agisfot. This is a program we're going to use. This is a Agisfot Metashape Professional. Make sure you have the professional version, or you can't really do orthomosaics for 2D type farm work. So I'm going to minimize this real quick, and I'm going to go to the file. Once you get the file from your Parrot Sequoia camera, you can either plug into it and download it USB, or maybe you pull the SD card out of it. You should have some file like this, and it could be number like 0025 to depend on when it was taken. It could be 001 or something. If you open this up, you're going to see multiple images here. For instance, we have the green band image, we have the NIR, we have the red. The REG is actually the red edge. And then as the last one, we have an RGB, which there's an imager that saves the red, green, and blue in a red, green, and blue image. And these are normal images. These are like black and white images. So that's what you have. Now, the problem with getting this in the Agisfot is you can't have the RGB images in with the red or the NIR or the green images. The reason for that is Agisfot is going to try and assemble those, take the individual images, and it's going to try and make a mosaic with multi-layers as all one image. And having the red, green, and blue in there will mess that up. So the first thing you want to do to this imagery is you want to click New Folder. You want to say something like RGB data. I just make it a subfolder in here. So there we have a folder for that. I then go to the View. Let's go down here. I click this, and what I'm wanting to do here is I want to separate and actually copy the RGB data into that RGB data file. Okay, so if you look here, all of these are TIFF files. That's for those black and white ones, the NIR, the red edge, things like that. This is a JPEG file. So, and it's a smaller file format that has 3 bands encoded, and this is like normal camera type files. So what we can do is, an easy way to sort these is just to do it by type. And you can see now when I click that button, all of a sudden I have all my JPEGs here in a row. I can click on this one, scroll down, find where the break is. Here's the last one. Push down on the Shift key and left click. Now I've selected all of those images right there that are the JPEG files. Take and drag this over into that folder. Now you can see here we're only left with the green, NIR, red, and red edge, and then it cycles. Note that if you don't do this process, Agisfot won't work correctly in interpolating this data. You can go back here and you can see those have been taken out. Now all my red, green, and blue data is now in this file folder. Okay, well you can close that now. We'll go back to Agisfot now that we've prepped the data for what we want. Go to Agisfot. One thing I do like about Agisfot is it's kind of like a no in-between type program. You can go right to workflow, add photos, you can go align, build dense cloud, build mesh, and then you can just skip right to build orthomosaic. Sometimes that makes it really fast because you may not want to build the texture or the DEM, the elevations, things like that. You may not care about that at all. And a lot of times you just want the 2D orthomosaic. So in this program, you can skip all those really easy. Doing that and having a fast computer, we've been able sometimes to do 60 acres in less than 10 minutes, putting them together, where it's anywhere from 1 to 200 photos. So then we go add photos. right here. Oop, let's go back one. I picked the wrong one. Let's go to desktop. That was 025 right there, and there's my photos. Now what you want to do here is you want to select all the photos, but you want to be sure you select a whole set of the 4. Because what Agisfot is going to do, it's going to take the first one, which is the green one. It's going to use that for making the map and tiling it and piecing it together and figuring out where the each image goes. And then it's going to follow that up with the NIR red and red edge that correspond to the green. If you highlight an odd number of photos, it won't be able to do that. So lots of times you have extra photos. Our camera, we just turn it on timed. It's on a little Phantom 4 with a little gimbal. It takes off. It's taking photos the whole time because we just take off. We use actually Pix4D Mapper to actually fly the route, and it's taking photos the whole time. And then when it comes in and lands, it's still taking photos. So you can see here, you know, I was taking off. You see my truck where it is. We're getting up to altitude. It's somewhere here we actually get to altitude, and the drone starts flying the field. Okay. So what we're going to do is we're going to select the photos we want. Just try and get the ones you want. You don't want to gunk it up with a lot of extra photos if you can. Most of the time it'll work with extra photos. Sometimes it won't, depending on what they're like. So remember how we started with green. We're going to go here and find where it starts. This looks like a good starting point. Here's a green one. Then we're going to scroll down. We want to find the end of the set. You can see here where I did the field, and then I got to a point where it was coming down and I was landing. Oh, let me say one thing right here. If you are trying to calibrate the imagery, there is a sunlight sensor on that camera, but you know, some people like to calibrate the imagery. We actually throw a target down. This is a white, gray, and a black. I think the gray is actually 27% or something, and you can actually get some photos of that when you land or take off to get some of that data. I don't typically incorporate that in when I'm just doing regular 2D photos, as the camera will adjust itself, you know, pretty well for a lot of work. And a lot of times we're just doing a per field analysis. If you do fields over like several weeks or months and the sunlight conditions are vastly changing, you may want to try and use a calibration data to keep it calibrated and to keep the correct sunlight levels for multiple days of imagery. So we're going to find the end of where I flew it. Right here looks like a good spot. In this data set, it's green NIR and red. So red edge would be the last photo. And this one actually looks like probably right here was before I started landing. We're going to hit the Shift key, left click the mouse button. It highlights those photos, and I'm going to say open. Now Agisfot is going to show you this screen. And we're not going to make single cameras here. We're actually going to make a multi-camera system. So we're going to have it take each imager, or each photo from each imager, the NIR, the red edge, and the green, and we're going to have it put into one image that has all those bands combined. The nice thing about TIFF imagery is it can have multiple bands, more than 3. JPEGs can only have red, green, and blue, or NIR, green and blue, that can only hold 3 bands of data, but TIFF can hold more than that. Now, that can be good or bad. For a lot of you guys who are trying to analyze it with some program like ImageJ or something, a lot of times JPEGs work the best. They're readable by a lot of programs, and if you make these multi-wavelength imagery and TIFF files, and it's got 6 bands in it, you may find it that a lot of programs won't read that. So do keep that in mind. You may have to get a special program to actually analyze and look at the individual bands in this photo. So when you go here, you hit OK. So now it's going to load them all up. You can see them right here. We can see the GPS worked because I see these little blue dots. And what we're going to do now is, I usually don't want the crossing patterns, so I'm going to go strip those out. So if I scroll down here, I should be able to see somewhere where it crossed. And this is one right here. Now you see the red dot come up? That means I'm going to minus that photo from the analysis because I don't really need it. So I'm going to highlight, select like maybe these 3. Oops. Let's go to this one. Hit the Shift key as you do this. Oh, sometimes it doesn't work right. Hit minus. Lots of times you can highlight more at once, but it's not working correctly there. I'm going to minus that one. I'm going to try and do that for all these crossing photos that I don't really need or that I don't want added. This is a good way that if you highlight all the images in the folder and you forget, and then you get in one spot and you say, oh, there's some with you know, had a cloud cover or the drone was twitching and the image was blurred or something like that, you can actually go in and minus that from your analysis, and it may help it do a better job. Here's another one. I can see right here where it's turning. Let me hit those. Oops. I'm going to hit Control on these. For some reason my select's not working very well. And then we minus those. So these in the light blue are minused from the analysis. Those in the dark blue will be used. So let's see if I can go down. Here's another spot where it was turning. You can see that's right here. Going to minus that. This one's got a little turn on it, so I want to minus it. And mind you, you don't always have to do this. Sometimes it'll work, but I have seen situations where it hasn't worked because of these photos that were turning. So going to minus those because they look a little bit twitchy. Maybe not this one. And I'm hitting the shift and the left mouse key to select those. So now I got rid of those. Now I may not want this crossing one, so let's go see if I can find it. That one may be hard to find. There it is right here. So let's go ahead and get rid of those. I'm not sure I need that. Got a lot of them right there. Minus those. Still looks like I need a few at the end. And probably those. Okay, so there we go. Oh, well, we got a little bit of it here too. Let me find these. There's some right there. Maybe we just won't worry about those. We'll see. That was probably at the beginning. Yeah, it was. I'm going to leave those in there just to see what happens, to show you that sometimes it'll work and sometimes it won't. So now when you get to workflow, the only thing you need to do if you're just straight going to make an orthomosaic or a 2D image of farm field, you can go straight to Align Photos. Just hit OK. Hopefully everything's been the same here. I just use medium. I've tried high and low, and I really can't tell much of a difference in anything, so I just use medium resolution. Now this is going to go through. If you want to see something interesting, you hit Control-Alt-Delete. You can find out how good your computer is. You can go to Performance, and this I can put it right here, and I can see what I'm actually using in this process. So these programs from testing, we found out that they use the CPU mainly, which you can see right here. They do use the GPU in some parts. You know, that would be like the CUDA and stuff, where it can send processing power to the parallel processors in the display card, but not as much as CPU. The CPU is the main thing you use. We've even found out for pretty big data sets, we really don't even use that much memory. Right now, we're using like 10 gigabytes out of 50, so not that much. We do run solid state disk in case we have to do some writing to the disk. Say we only have memory of like 10 or 12 gigabytes and it started using the disk. That will greatly speed up things for you. So we do run a solid state disk on all our computers. If you ever need help building a computer for this process, give me a call. You can find my info at the LSU Ag Center under Dr. Randy Price, and I can help you out on speccing a computer. We actually have a paper on the LSUAgCenter.com website where it'll tell you what resources to look for and give you some idea of good processors for this. Okay, so now we're getting ready to be done. This is a research field. This one's not that big. I think it was like 10 or 15 acres. And we're almost done with the process. If you have lockups when you're doing this, go back and check your hardware. You probably have some memory or something that's not spec'd out right for the CPU speed. Try lowering the CPU speed and some things like that if you're using a home-built computer. Okay, so here we go. If I spin it like this, I can see these are all the points where it's aligned and found matches. Here's our research plots over here. These are all the images. These black bars are the inclination of the image, that it thinks how it was inclined. Here's an image where it wasn't able to use that one. Okay, from there, we can go straight to build dense cloud. This process doesn't take very long usually. You can see the CPU is being the most used device in here, and GPU is not really used all that much or anything else. I will stress again, you want to buy the best CPU you can buy. We actually use Ryzen Threadrippers in all our stuff. So don't spare expense money on CPU. Put all your resources into that if you're making your own computer to do this type of process. Okay, so still taking a minute, not that long, but it does take a little while. If you get like thousands of acres, I'm not even sure you could do it. It'd be so big for your computer. But when you start getting to those levels, this can actually take, 1 to 2 hours on a high-end computer, or 6 to 10 hours on low-end computers. Now, some of you guys may not want to do this process, and you may just want to use the mapping that's available online. Those work pretty good too. The only reason we do this is sometimes we're out in the field, we want to see what's out there immediately, and there are programs that can do some live mapping for you, but we'll actually have a computer we put out in the vehicle. We have some batteries that can power it and things like that, and we'll actually do this out in the field in about 6 or 10 minutes and then go see what our research results look like and compare it to what we're seeing out in the field. Okay, once you do that, you need to build the mesh. These are the 3 operations you have to do if you're going to do the orthomosaic. If you try to do the orthomosaic before that, it'll tell you go back and do that. Now here, you could try and just do the orthomosaic, but it's going to tell you save the file. So save in PX format before processing. At this point, I guess it wants you to save it so that you don't lose it. So hit save. Be careful here because Agisfot does remember the last folder you were in, and you'll tend to save it in that last one, forgetting that I am now in this folder. So you want to reselect that. I just put something like Agisfot so I know what program I was using. I usually put medium, and that's about it. You can do 1, 2, or whatever you want. Save the project. Once you've done that, redoes this. We can spin it back up here if you want. Go down to orthomosaic, hit build. Now we'll wait a little bit. This process does take a little bit of time also. It doesn't take that much time as much as aligning the photos. That's definitely the longest process. But you can get anywhere from a couple to 10 minutes or so doing this process. Again, look over here, CPU, main thing used, GPU, hard disk. The disk being used a little bit because it's trying to write data, but this stuff really not being used as much as the CPU. See right here how it's using the disk to write data? This is where you want a solid state disk because those are much faster than some of the disk drive disk. They have a certain RPM that they spin out. Okay, so just waiting for this to get done. It's almost done. Voila. Now you're probably saying at this point, where is it? Well, if you go here, you click on this. This is all the different maps and things you can get to. And if you did that process right, you should see one at the bottom that says orthomosaic. So here it is. This is a 2D image of all those features, of all those images put together for a farm field. You can scan around. We can see our plots. This was, I think, a brown rust test in corn. You can see here where there's some plots that were not sprayed. They're not as bright, and ones that were sprayed in different varieties and things. You can see here where this is just plain soybeans. We weren't using this field this year, so they just planted it in soybeans. We get this a lot in Louisiana. There's places where things grow really well, like right here, and places where things don't grow very well, like right here. And you can see strips here. Probably at some point, this was used in some tests, and they had high fertilizer or something. We tend to have a lot of clays in this area. And the clays actually do kind of hang on to the fertilizer from year to year. We've had times when somebody had a fertilizer test, we come in next year, try to plant something, and if it's some other type of fertilizer test, you can't come and plant behind it because there will be residual fertilizer that you will see in your plots or in the field. Usually you got to go through and strip this out with some other crop, growing a crop with no nitrates put on, and then hopefully the year after that you actually have more of a base level that you can use for studies. So this is the image you get. From here, you might want to save this, although this one isn't as useful as you think because you may not be able to read the multi-layers in this. It's just going to save probably you can save it as a TIFF or a JPEG. They do save the same. I've tried it both ways. It's really not a multi-band image like you think, but you can give it some name. Let's say just ortho 4-band because this is 4 bands. Now, some of you may say, why is it blue? The reason it's blue is because I saved it as green, red, NIR, and red edge. I think that was a level, or it was NIR, red, and red edge, something like that. It just stuck those in the red, green, and blue spots, so they're not proportioned right, so that's why this just looks blue. Now, for some of you who want to actually get some useful data out of this, more than just a visual, because this is multi-band data, you probably want to go up here to the paint, the little paint deal, and this is the Raster Calculator. So this is going to allow you to put like an indices. An indices is like a calculation between the bands. These are real famous in agriculture, like NDVI red or NDVI blue or NDVI green or things like that, where there's actually a calculation or ratio that you perform between the different bands to help extract data that you want to see. So in this one, we're going to do NDVI red. So when you pull this up, you'll see the different bands that are in this image. So let's do NDVI red. That NDVI red is the red, or the NIR minus the red divided by NIR plus red. So we'll put a parentheses. This was something I was playing with before. And now I want to put in, let me delete that, NIR minus red, parentheses here. You do this just like a calculation in any spreadsheet or other things you do using these numbers. Parentheses again, then I do NIR plus red. All right, so if everything's right, this little green check should come up showing that your equation can be used. You then hit apply. You can hit OK. And this is the NDVI image. Now here, it's not really scaled maybe as well as you want, but if you look at this where it's green or red, that's the highest numerical value. Remember, NDVI a lot of times, NDVI red, the closer you get to 1, the better the biomass, or the better the chlorophyll, or the better the health of the plant, or the better plant population. The lower you get near 0 would be just like bare soil or bare asphalt or something like that. So what you can do is, it still might not be as useful as you want. You can go back to this raster calculator, and if you go to the palette right here, right now we have it on a heat scale. Now one thing you're going to want to do is see how this is proportioned. You're going to want to hit auto. This is going to reset the scale to match the new histogram of the raster you just calculated. It won't be like that beforehand. So you want to hit auto, and then you want to hit apply. If you want to, you can grab this over here and just drag it around. Now this now has made the 0 to 1 range fit the lowest to the highest value of the histogram for the indices values you just for the whole map. And you see now, remember how good it was growing right here? This is solid red. That was a good growing spot. This is bare soil right here. That's blue, which shows about 0 NDVI. Here's our corn test plots. And if I click, let's see, if I get rid of this, I can scan in and out, and I can scroll it around. So these are our corn test plots, and you can see how here was an area where this is being invaded by brown rust and some leaf rust and some other things. I think it's called brown stripe or something. I'm not an entomologist, but that's what he told me. And it was coming in from this side of the field. They did this on purpose. This was the less rust-prone plants. And you can see they're higher NDVI than these plants. Now what you can do with this image is you can save this one if you like. You can hit generate, export, and you can save this in a JPEG. And I might put something like ortho. This was a heat. This was NDVI. You might want to put something to remember what was NDVI red, and you might say this was heat scale, which meant that red highest and blue lowest. You might want to do something like this because you'll forget what indices you used and things like that, because I'll usually try multiple ones to kind of get a look at things. Now, lots of times I use heat scale because it really brings out that this is really good and this is really bad, and you see it heightened to your eyes. You may not want that. So if you don't want that, you may want to go back to this palette, and you may want to select NDVI scale. Here's the NDVI one. You may want to redo these. You can hit apply, and here it is in some NDVI scale where the darker green would be better growing, and the not as good green would be either bare soil or water or not good growing crops. So, all right, so there's an idea how you do that. You could go back and use the imagery to try and extract data out of it. Sometimes it's better if you strip out one of the bands and you just say the red, green, and blue bands, or the NIR and the green and blue, and then you're able to get that in Agisfot and stuff like that to actually analyze it. If you do want to analyze this and try and get numbers out of this data, there's several ways to do that, and I'm just going to mention these. I'm not actually going to do it. Sometimes you want to put in here that you only want one band, such as the green, and I'll show you an example of that. Band 1, hit apply. This is now just the green band. Go to palette, hit auto, go to here, hit Grayscale. So what Grayscale is going to do is it's going to save it in a format, like say you say a JPEG. This will be in a format of 0 as the darkest color to 255 as the brightest color. Hit apply. Oop, still didn't come out. Hang on. Let's try the red. Palette, auto scale, there we go. Oh, sorry. Actually, I don't want grayscale. There we go. So now you've got an image that is just a red band, and where it's dark is where it's being absorbed, which is what plants do. They absorb red. And where it's white is less absorption, which is what plants do, and that will be closer to 255 on the scale that JPEGs are saved at. You can then go in and save this if you want, because you may want to analyze this later on, and you can hit export. You can save that as a JPEG, and then you can say this is the ortho, and this is the red band only, and you can say this is black and white. And if you want to, you could say that, you know, the 0.8 value was actually 255 and some things like that if you need to. You may want to write that down, because if you start doing hardcore number crunching, that may be important. And boom, I can save that. Okay, well, that gives you an insight on, or gives you an example of how to get Parrot Sequoia data into the Agisfot program, where you can play around with it, make some orthos, print them out, do some different indices, things like that. If you have any questions, I can be reached on the lsuagcenter.com website. My name's Dr. Randy Price, and you can look me up there. You can send me some email or call me on my cell phone, whatever you'd like to do. All right, thank you for your time, and I hope this helps. Thanks. Bye-bye.